Alright, so here we go. This is section 3.8, Math 1. We are simplifying rational expressions. We just got done doing long division, dividing polynomials, and now we are simplifying expressions. And there's two things in that. The first thing is excluded values. Write that down, excluded values. Excluded values are any values that x cannot equal. Okay? We can say x cannot equal 2 and 0. Right? That would be two excluded values. There might not be any excluded values. There might be 1, there might be 2, there might be 3 excluded values. Excluded values are values that x cannot equal. We already know a little bit about this because we grabbed rational expressions last week and we said, and we did the domain. What is the domain of this rational expression? We have a way of saying that, right? What is it? Domain equals x cannot equal what?
0.
0. Why? Why cannot x equal 0? Why?
Because it asks it to.
Right, but why? I'm being like a 4-year-old. Why? You cannot divide by 0. I don't care how high up you go, you can never divide by 0. So write that on your paper. Dividing by 0 is bad. Okay, that's over a simplification, Bab. It's bad. Okay, you can never divide by 0. Okay, so excluded values deal with that. I don't care about the top. The top can be anything. The top can be 0, right? 0 over 4 is fine. That just equals 0. You do it on your calculator, 0 divided by 4, it says 0. But if you say 4 over 0, right, what do you get on your calculator? Error, right? It won't do it. You cannot divide by 0. Your calculator can't do it. You can't do it in Cal 1. You can't do it in Cal 5. Okay? No matter how high up, you do not divide by 0, ever. So, what are some rational expressions? Okay, see, simplifying rational expressions. What are some irrational expressions that have excluded values? How about 8x over 6? Does it have an excluded value? Is there a value that x cannot equal? It can be 8. I'd plug in 8, I'd get 64 over 6. No problem. 0. I'd get 0 on the top and I'd get 6 on the bottom. Is there an excluded value in this problem? No, there's no excluded value. It's a trick question. Okay? I probably shouldn't have done that first. But write it down. There is no excluded value. And you can just say EV. Okay? What was the EV1? What was the EV1 in just electric vehicle 1? General Motors made it in the 80s. It was an electric car.
Oh yeah, I remember.
Right? They did a documentary, Who Killed the Electric Car. Have you ever seen that documentary? It's outstanding. EV1. Google that. Huh? Old. I'm an old man. Way older than you.
But you're young at heart.
Sometimes.
Alright. So here's example 2. What is the excluded value of this rational expression? 0. Now watch. Everybody's eyes up here. What's the excluded value now?
0.
Still 0. What's the excluded value now?
0.
Still 0. Oh, tricky. What's the excluded value now?
0. 1.
0.
Still 0. But actually it's 0, 0. But how many times do you have to write it?
1.
One time. Okay? What's the excluded value now? 0. If x is out there by itself, okay, whether it has a number out front of it or an exponent on it, it's always going to be 0. Okay? It cannot equal 0. Why? Because if I stuck in 0, I multiplied it by itself 21 times, and I multiplied it by -2, I would still have 0 in the denominator, and that's bad. Okay? Not bad, but bad. Alright, so here's your next example. Alright, first question is, how many x's do you have?
2.
2. You have 2 in the denominator. We're only looking at the denominator. What's the denominator mean? The bottom of the fraction. Down. Denominator. That's fine. That's a way of remembering it. Alright, so we got x and x minus 1. We got 2 x's. How many excluded values are we going to have? 2. What are they? 0. And what else? Positive 1. What you are actually doing here is you are setting this not equal to 0. You're setting the denominator not equal to 0. And you're looking at it and you're saying, well, x can't equal 0, that value. And what else can x not equal?
Positive 1.
Positive 1. Why? Because if we stuck in 0, we'd get 0. If we stuck in 1, we'd get 0 in the denominator. How about positive 4? Is that an okay value?
Yes.
You sure about that?
No.
It can be 0 on top. Okay? Every day, all day long, it can be 0 on the top. 4 is okay. But 0's not okay, and 1's not okay. Alright. What can x not equal now?
Positive.
I don't know. You cannot tell me by looking at it right now. However, if you factor the denominator, if you set it not equal to 0, and you factor that out, you pull out a GCF. What is the GCF of 2x squared and 2x? 2x. What will be left?
X minus 1.
Minus 1. Still not equal to 0. I factored that out. You've got to remember how to factor, right? What's rule number 1 of factoring? GCF. GCF. 2x is my GCF. You can't forget how to factor. Once I factor out that x, then what are my excluded values? What can x not equal here? 0. What can x not equal here? Positive 1. What was the clue that there were going to be 2 excluded values? It was x squared in the beginning. That told us that there were 2 excluded values. Okay? Questions? Alright, you should be writing these examples down. Not just sitting there watching the show. How many have we done so far? Alright, how about this one? Can x equal 25?
No.
Sure it can. 25 squared would be 625, I think. 625 minus 25 would be 600. I can get 600 on the bottom. X can equal 25 all day long. Alright, Savannah says x can equal 5. Anybody agree with her?
Yes.
I think so. I don't think x can equal 5. I also know, because that's x squared, that 5 is not my only answer. What's the other answer? Not 0. Let's try 0. All right, you just said 0. Let's try 0. What's 0 squared? 0 minus 25. Did I get 0 on the bottom? No, I did not. So 0 is fine. Okay. All right, now how'd you get that? Did you guess?
No, I see it.
All right, how? Does x squared minus 25 factor? Do you remember that that's the difference of perfect squares, and it factors into x plus 5 and x minus 5? Both of these are not equal to 0, so what does x not equal? 5 and negative 5.
Did you put 5i?
Plus minus.
Why would you put 5i? Are you taking the square root of the negative number? No. Yes.
So we're really just trying to figure out what makes it the bottom equal 0.
Say that again, Nash. You just summed it up perfectly.
Trying to figure out what makes the bottom
What makes the denominator equal to 0? Outstanding. Exactly right. Questions? All right. So let's change it up a little bit.
Would you let us try this on our own?
Okay, sure. I'll give you a hint. How many excluded values do you think you're going to have? 1. Why only 1? There's only one x. You're only going to have 1 excluded value. Okay? Raise your hand if you think it's 9. Anybody think the answer's 9?
What's next to do?
Do you're wrong. That's right. 9 times 3 is 27. 27 minus 9 is 18. 18's okay. 9 is not an excluded value. You can't just say it would be 9. If that was the case, eyes up here. If that was what I had on the bottom, then you could say 9. But the 3 messes things up. So I have to set it not equal to 0. I have to add 9 to both sides. 3x does not equal 9. Then I divide both sides by 3. And what does x not equal? Positive 3. That's my only excluded value. Can I check that? Yeah. What's 3 times 3? 9. What's 9 minus 9? 0. And 0 in the denominator is? Bad. Question? You can look at it, figure it out. That's fine too. Savannah. You can just say the excluded value is 3. If you do this, quiet please, x does not equal 3, what you're actually telling me is the domain. And I don't mind if you write it like that, but when it's asking for excluded value, I just want to see the number. Okay? You do not have to do this. Okay? Alright, let's see another. What are we doing here? What are the directions going to say? Nope, they're not going to say simplify. This is the first part. There's 2 parts. The first part is find the excluded value or values. Okay, let's try another. Sykes, can you look at this one and tell me the excluded values? No, you cannot.
We don't do anything to the top, do we?
We don't mess with the top.
I look at it. Please stop talking. You're talking when I'm talking. You're going to go to ISS. What's our time, James?
12.
12 minutes? Okay, good. Alright, so here we go. We know that we're looking at the bottom. We know that we're going to set that not equal to 0. We know that we're going to have to factor, right? That's the most important word in this section, is being able to factor trinomials where a is equal to 1. Okay, this is a very simple trinomial. We put our parentheses. What do our signs have to be if that one's negative?
Plus and minus.
One's plus and one's minus. We know we got x and we got x. What are the factors of 12 that have a difference of positive 4?
6 and 2.
Positive 6 and
Negative 2.
2. Still not equal to 0. So what can x not equal?
Negative 6.
Negative 6 and positive 2. 2 excluded values. Okay? 2 excluded values. And those are what x cannot equal. Okay? Alright. Any questions? And we're going to move on to simplifying. Any questions? Love it?
Would they ever go, I mean, it's always going to be 1 or 2 values, right?
What if I had an x out front? What if I gave you that? What would your 3 excluded values be? 0, negative 6, and positive 2. Okay? So, there could be more than 1 or 2 excluded values. Okay? Could there be no excluded value?
Yeah.
Yeah, that was the first example we did. Okay? Alright, this leads me into my next section. Okay? Eyes up here. Everybody's paying attention and following along. Let's say that the directions, instead of saying find the excluded values, said what? Simplify. This is the meat of the section. Can you simplify rational expressions? And the name of the game is basically, can you factor? Okay? They're going to give you binomials and trinomials. They're going to give you monomials and trinomials, monomials and binomials, and see if you understand when you can cancel and when you can't cancel. It boils down to knowing that the only thing in the universe that x plus 6 cancels with is what? X plus 6. I can only cancel x plus 6. This is the first example that I might give you. X plus 6 over 6. And everybody wants to cancel those 6's. Write this down and say you cannot cancel here. Nothing cancels. The only thing in the universe that cancels with x plus 6 is another x plus 6 on the bottom. If you got one on the top, you need one on the bottom in order to cancel. Nothing cancels here. These 6's don't cancel. They sure want you to cancel them, okay, but they don't. Why? Because that's a binomial. Binomials only cancel with other binomials. How about this problem? 12x cubed over 6x. Can I cancel there?
No.
Yes.
Can I cancel the 12 and the 6 and the x cubed and the x? Sure I can. We just did that last section. Why is it okay to cancel here and not here?
Because they're in front of the x.
You're on the right track. These are both what? Monomials. Good, Logan. These are both monomials. They're one term. So the 12 and the 6 cancel, and I get a 2 on the top. The x's cancel, and I get what?
X squared.
X squared on the top. This is x, x, x. This is x. They cancel, and I have x squared left on the top. Okay, so that's a review. Now let's go back to this problem. If the directions had said simplify, you have to factor, just like you had to factor to find the excluded values. And the x plus 6's, what happens to them? They cancel out. And so my answer is x minus 2. And you're done.
So that's
Right.
the whole thing.
You tell me. Is that right? Does anybody have a problem with that?
I don't know.
The answer is x minus 2. Unless somebody has a problem with that. David?
One question, do they put x equals or nothing?
No. You're just simplifying. It's an expression. There's no equal sign.
Wouldn't that be positive?
Why?
Because you have to change it.
You don't have to change it. You don't have to change it. Nobody has a problem with what I have on the board here? Roy?
Isn't it in the denominator?
That's right. The x minus 2 was down on the bottom. Where did I put it over here? I put it on the top. You better not do that. It's a common mistake. The answer, guys, is 1 over x minus 2. If that x minus 2 is in the denominator, you have to keep it in the denominator. You can't just arbitrarily put it in the numerator. You've got to keep it on the bottom. Okay? There's nothing complex about what we did here. Okay, let's go over it. I factored the denominator into that and that. This canceled. X plus 6 and x plus 6 canceled. I was left with x minus 2 in the denominator. Nothing was on the top. So my answer needs to be 1 over x minus 2. Has to be. Questions? Any questions? All right, James, what are we looking at? What time we got?
18.
18 minutes. Let's hit stop.